Okay friends, welcome back. In this part of the video presentation on database design, we will talk about relationships. So in the previous part we talked about entities, the kind of attributes entities may have and the kind of properties those attributes may have. In this part we will talk about relationships between or among entities. So what is a relationship? A relationship is some kind of natural business association that exists between one or more entities. So some kind of natural business association, some kind of relationship between entities that is relevant for business purposes. So the relationship may be represented by an event that links the entities or some kind of logical affinity that exists between those two entities. Which entities are linked is something that it seems to be on the side of the art of system analysis and design. I mean, you need to decide which entities are linked and which entities are not linked. But this linkage is represented by a line. You see that this line has certain ends, and just to jump forward, those ends, they represent cardinality, or the numerical property of the relationship. But for now, we'll just say that relationship between entities is represented with a line like this one. So in this specific example, we have a student entity and we have a curriculum entity. Curriculum means like some kind of set of courses, so let's just call it major for simplicity. Okay. So the question that you need to ask yourself is there any kind of relationship between students and majors, so students and the curriculum? Okay. Now definitely there is a relationship, because students, they enroll in certain majors, so they enroll in certain curriculum, certain study plan. And then majors, curriculum, so study plans, they are being studied or they are being populated by students. So there is a relationship between students and curriculum that seems to be going both ways. Students are linked to curriculum, and curriculum is linked to students. Now, one important comment about relationships is that relationships are always, in the context of ERD, are bidirectional or bidirectional. In other words, they go both ways. Okay, so there's a relationship going this way, and the relationship that is going this way. Okay. Now, each relationship can be characterized further in terms of the cardinality. Okay, so what is the cardinality? And I know this definition sounds a bit complicated. It's the minimum and maximum number of occurrences of one entity that may be related to a single occurrence of the other entity. So once again, it's the minimum and maximum number of occurrences of one entity that may be related to a single occurrence of the other entity. It sounds something like, to kind of explain it better, in a practical way, cardinality is something along those lines. If here we have two entities, students and curriculum, or student and major. Okay? So cardinality means this: if you take one instance from this entity, okay, what is the minimum and maximum number of instances in this other second entity that this instance is related to? Okay, so if you take one student, in theory, each student can be enrolled in one or several. So one is the minimum, maximum is several majors or curriculum, right? However, remember this rule. Because all relationships are bidirectional, cardinality must be defined in both directions. Okay, so the same thing needs to be done here. If you take one major, what is the minimum and maximum number of students that this major curriculum can be associated with? Okay, so maybe at the minimum it's 0, because let's say we have a new major, a new curriculum, and no students have enrolled in this specific curriculum yet. So minimum is 0, maximum is many. You can have many students in one specific study plan or one specific curriculum. Okay, so that's what cardinality is all about. You take one instance and you see how many instances in the other entity it can be related to, minimum and maximum. Okay. Now the specific notation that is used to represent cardinality is the so-called Crowfoot notation. Now the reason it's called Crowfoot notation is because this specific notation looks like a crow foot. It looks like a foot of a bird. Okay. Now, one stick means one. One or two sticks like this means one, exactly one. This circle of 0 means 0, and this stick means 1. So basically, this notation means minimum 0, maximum 1. Okay. Now, once it's more than 1, let's say it's 2, 3, 4, 5, or even more than that, indefinite number of instances, you say many. So once it's more than 1, 2 and above, you say many. So this notation represents minimum 1, maximum many. So Crowfoot represents many. Okay. Here you have minimum 0, maximum many, and here you just have many. Okay, one instance is always associated with many instances in the other entity. Okay, so this is the Crowfoot notation. Just to make a drawing. So this is a bird, for you to remember. A crow. It has wings, and then crow feet look like this. So that's why it's called Crowfoot notation, because it's similar to this. Okay. So this is a crow. So I think this notation is fairly easy to remember. So if you go back to our previous example, this is what we have. One student going this way. One student, because the cardinality is always on that kind of side, the opposite side. So one student at the minimum is related to one major. So let's say we have a rule at the university that each student needs to have a major once he enrolls in the university. So minimum is 1, maximum is many. One curriculum or one major is associated at the minimum. 0 means we can have a situation where we have a new major, there are no students enrolled in that major yet. At the maximum, many students are enrolled in one particular study plan or curriculum or major. Okay, so this is how cardinality is expressed. Now, just one quick comment. Degree is the number of entities that participate in the relationship. You can have a relationship between 2 entities and it's called binary. You can have a relationship between 3 entities and it's called ternary. Okay? You can also have a relationship between different instances of the same entity called, in that case, it will be called recursive relationship, meaning the relationship to itself. Okay? It will look something like this. So we have an entity and it's related to itself. And here we have cardinality. Something like this. Okay, so that would be a recursive relationship. Okay, but all I'm trying to say is that the relationship on your diagram does not have to be like this, involving 2 entities only. It can be something like this. So here we have a relationship between 3 entities, and this relationship is implemented. The so-called ternary relationship is implemented by including the so-called associative entity. For now, I will not expand on that. I will just say this is an associative entity. It's used to link several entities together. Okay, but what I'm trying to say is that here we have many entities participating in the relationship. So the relationship seems to be between n-ary relationship between 4 entities, or I'm sorry, among 4 entities. Okay, so it doesn't have to be 2 entities only. It can be a complex relationship like this one. Now, this is something that is very important to understand, the concept of a foreign key. Because now that we understand what relationship is in principle, we'll talk about implementing relationships. How do we implement relationships? Now, a short answer to this question is that we implement relationships by using foreign keys. So what is a foreign key? A foreign key is a primary key of an entity that is used in another entity to identify instances of a relationship. So basically, whenever you have a relationship between 2 entities, okay, so you take one of the entity's primary keys, and we talked about primary keys before. So primary key is an attribute that is a key attribute, meaning that this attribute assumes unique value for each instance of that entity, right? And we designate that key attribute as our primary key, meaning the identifier, or PK, primary key. So foreign key is a primary key from another entity. Okay, so a foreign key is a primary key of one entity that is duplicated in another entity to identify instances of a relationship. Okay, now a foreign key always matches the primary key in another entity. A foreign key may or may not be unique, generally not. A foreign key may or may not be unique, generally not. The entity with the foreign key is called the child, and the entity with the matching primary key is called the parent. Don't worry if some of those things they don't make sense to you yet. I'll show you an example of what we're talking about, of how primary keys are inserted, and then maybe you can go back to this slide to reflect on it more. So what I'm trying to say here is that in any binary relationship, or not necessarily binary relationship, but when you look at the relationship between two entities, it could be like as a part of a ternary relationship or n-ary relationship. One entity is a parent entity, and one entity is a child entity. Okay, so once again, in a relationship between two entities, one is a parent and one is a child. Okay. Now, how do you distinguish between parent and child entities? Now, the rule is fairly simple. Child entity is always on the many side. Okay? So once again, child entity is always on the many side. Okay? So let's think about the following scenario. Let's say we have two entities. Okay, one entity is called dorm. And then we have another entity called student. So basically here we are modeling a part of a database that can be used by universities such as Murray State. Okay? So we decided that we want to keep track of dorms, meaning the buildings, the residential colleges where students live, and also we want to keep track of students. Okay? Now, is there any kind of relationship between dorms and students? I mean, I would say yes, because students live in dorms and dorms are populated by students. And overall, you want to keep track of which student lives in which dorm or residential college, as we call them here. Okay? So there is a relationship. Now, let's talk about cardinality of this relationship. So if you take one student, what would be the minimum number of dorms that this student lives in? So if you take any student at Murray State University, what would be the minimum number of dorms that this student is associated with? Okay, so think about it for a second. What would be the minimum number of dorms that a student is associated with? Well, probably zero, right? Because some students, they don't live in dorms. They're the so-called commuters. I think that's how we call those students at MSU, right? So they commute to campus, they don't live on campus, so zero. Now, what is the maximum? Now, the maximum is 1 because, I don't know, it doesn't make sense for a student to live in more than one dorm because, you know, why would you rent 2 rooms in 2 different dorms? So it doesn't make sense, right? So student lives at the minimum in 0 dorms, at the maximum 1 dorm. Now, if we go this way, 1 dorm is associated at the minimum with how many students? Think about it for a second. I mean, it depends on the specific scenario. I would say 0. So let's say it's a new dorm. I mean, it's possible that it's a new dorm or the dorm is being kind of cleaned out. So no students are assigned to this dorm yet. And maximum many, right? So because many students can live in one dorm. So we have this relationship where here we have 0 to 1, minimum 0, maximum 1. Here we have minimum 0, maximum many. Okay? So again, let's go back to our definition. In a relationship between two entities, one entity is a parent entity and one entity is a child entity. Now think for a second, which entity would be the child entity and which entity will be the parent entity? Think about it for a second, giving those definitions. Now, giving this definition that the child entity is always on the many side, this entity is a child entity. Okay? And this entity is a parent entity because it's on the one side, according to the definition here. Okay, so you need to make sure you remember this rule, you know, that child entity is always on the many side. So here we have many side, therefore this is a child entity. Here we have one side, therefore this is a parent entity. Okay. Now, why this rule? Why this distinction is important? Well, this distinction is important to understand which primary key you will take from which entity and where you will insert it. Okay. So eventually, as I told you before, each entity is represented as a table. So here we have a table representing student entities. So once again, each row represents specific students. and here we have a table used for store information about dorms. Okay, so because dorms have unique names, I mean we don't have duplication of names in dorms, the primary key here can be the dorm name. Okay, so this will be our primary key, PK. Okay, and here the primary key is student ID. So the question becomes, which primary key do we take and insert into the other entity? Because one alternative is to take the primary key from the dorm entity and insert it here. Alternative number two is to take primary key from the student entity and insert it here into the dorm entity. So which option do we select? Well, the rule is that you take primary key from the parent entity, right? So which one is the parent entity? Dorm is a parent entity, right? We figured that out earlier. So we take primary key from here, from this parent entity, and insert it into the child entity. So in that case, dorm name, or here just called dorm, which is a primary key here, becomes our foreign key here. Okay? So the rule is this, to make it more general. You take primary key from the parent entity and insert it into the child entity. So that's the rule. Once you know which entity is a child entity, and once you know which entity is a parent entity, you take the parent's primary key and insert it into the child entity. And this entity becomes foreign key. Okay? Now, let me ask you this question. Why you cannot do the opposite way? Why can't you take, let's say, student's primary key, student ID, which is the primary key of the student entity, and insert it here? So in that case, we're going to have one more column here to be student ID. I'll just put a shorthand notation. And this will be our foreign key. So why can't we do it this way? So think about it for a second. Why can't we take student ID and insert it here? Why can't we violate this rule? So think about it for a second. Why we cannot do the opposite way? Now, if you think about it, it looks like you cannot do the opposite way because you will violate the integrity of this table. In other words, you will violate the structure of the database. So, for example, let's say somebody named Betty Arnold with the student ID 2144 moves into the Smith dorm. So what we will do, we'll add 2144 to indicate that Betty Arnold lives in this particular dorm. Okay, but as you well know, each dorm is populated by many students. So let's say another student, here we don't, let's say Lisa, right, moves to this dorm as well. We cannot take this cell and add another value, which is Lisa's student ID 3843. We cannot do that because the rule is that if you remember that tidy data paper by Wickham, one of the authors of RStudio, you know that it's a violation of tidy data principle. You cannot insert more than one value into one cell. Okay. Now some of you will say, well, why don't we add another column? And we add information about Lisa here in this column. Well, again, you are violating the structure of the database because the idea here is that once you design structure for a particular database, you just keep adding records. You don't change the parameters, the shape of the tables. Right? So by adding new columns, you're changing the shape of the table, which is not a good thing. You're violating the structure of the database. But with this scenario, you don't have to violate anything. Whenever a new student enrolls at MSU, you just add one row, additional row. You add student ID here, his name, and then indicate which dorm he lives in. So you're creating additional record. You're not violating the structure of the database itself. So that's why the rule is this. You take primary key from the parent entity. In our case, parent entity is a dorm entity because it's on the one side, and insert it into the child entity. Now, the child entity is a entity that is on the many side, right, as we saw in this particular slide. So student is a child entity because it's on the many side right here. It's on the many side. And in that case, the primary key of dorm, once inserted here, becomes the foreign key. Okay, so this is how relationships among or between entities are implemented using primary and foreign keys. So this concludes part 2 of our video presentation on Introduction to Database Design. Thank you for listening.